Hi, welcome back to the channel. In our last lesson, we saw how to solve partial fractions with repeated factors in denominator. We will continue with that same lesson today. We'll use this example to further explain how to deal with partial fractions with repeated factors in denominator. That said, let's get started. Our example says we have 14x squared plus 31x plus 5 over x minus 1 into 2x plus 3 all squared. Like I rightfully explained in our last lesson, the best way to resolve this is to equate this to a over x minus 1 plus b over 2x plus 3 plus c over 2x plus 3 all squared. Now if you observe, you see that this x minus 1, I just treated that once, while I have 2x plus 3 all squared, I treated that twice. Now I'm to take an LCM, the lowest common multiple, that's x now. Obviously the LCM of this will be x minus 1 into 2x plus 3 all squared. X minus 1 in this, I will be left with a into 2x plus 3 all squared plus b into 2x plus 3 in here. I'll have x minus 1 into 2x plus 3. 2x plus 3 in here will cancel 1. Then I'll be left with 1 of 2x plus 3. Now multiply by x minus 1, multiplying b, then I have this expression plus c now into x minus 1. 2x plus 3 all squared here. It will cancel 2x plus 3 all squared. I'll be left with x minus 1. Now the next thing I have to do is to expand this expression. Now if you look at this carefully, I can use binomial expansion to expand this, but we can also use factorization method. Since I have it just raised to power 2, let's quickly use factorization method. 2x plus 3 into 2x plus 3. So that this is the same thing as, that's 4x squared, 2x times this, plus 6x plus 6x plus 9. That will be equals to 4x squared plus 12x plus 9. So that this expression is the same thing as a now into 4x squared plus 12x plus 9. Let me now open and expand this again to expand x minus 1 into 2x plus, so that this is x times 2x, that's 2x squared, x times 3, that's plus 3x, minus 2x minus 3. So that this is 2x squared plus x minus 3. Now I can place this now to be b now. We can b into 2x squared plus x minus 3 plus c into x minus 1 all over x minus 1 into 2x plus 3 all squared. Remember that this whole expression is the same thing as 14x squared plus 31x plus 5 over x minus 1 into 2x plus 3 all squared. Now if you look at this expression carefully, you see that what I have at the denominator, what I have here as the denominator is the same thing as what I have here as the denominator. So we can just equate the numerator, or otherwise you can cross multiply, and at the end of the day this and this will cancel each other, so that at the end of the day I'll have my numerators equating to each other. So what I'm saying is I'll have 4a, let's expand this. I'll prefer to expand this. I'll have 4ax squared plus 12ax plus 9a plus 2bx squared plus bx minus 3b plus cx minus c to be equals to 14x squared plus 31x plus 5. Now let's rearrange what we have at the top. I want to collect like terms, so that 4a, I have 4ax squared plus 2bx squared plus 2b. Now you have x squared plus 12a now plus b plus c, that's into x plus 9a minus 3b minus c equals 14x squared plus 31x plus 5. Now let's remove some of this to let's remove some of this to create some space, so that now I can conveniently say that we can collect like terms. We can now equate coefficients, so that from here we can now say that 4a plus 2b will be the same thing as everything that has x squared, I will equate them to 14 is equals to 14. Then 12a plus b plus c, everything that has a that has x, I will equate them to 31. So I'm equating them to 31. Then those things are without any x, that's 9a minus 3b minus c is the same thing as 5. Let's call this equation 1. Let's call this equation 2. And let's call this equation 3. Now let's delete some space here to create some space here, so that my equation from 1, I can deduce that 4a plus 2b is equals to 14, so that my 2b is equals to 14 minus 4a, so that b from here is equals to 7 minus 2a. Now let's substitute this for b. Let's substitute for b in equation 2 and 3, so that in equation 2 we can conveniently say that this is 12a plus b. In position of b, we'll have 7 minus 2a now plus c is equals to 31. So that this is 12a plus 12 minus 2a, that's 10. 10a plus c is equals to 31 minus 7. 31 minus 7, that's 24. That means 10a plus c is equals to 24. Then in equation 3 also we substitute for b, that is 9a minus 3 into 7 minus 2a minus c is equals to 5. So that 9a minus 21 plus 6a now minus c is equals to 5. So that 9a plus 6, that's 15. That's 15a. 15a minus c. And here I have minus is equals to 5. Let 21 go to the other side, becomes positive, is equals to 26. Now from this equation here, we can now add, let's call this equation 4. And let's call this equation 5. Now I'll be adding equation 4 to 5, so that I now have 10a plus c to be equals to 24. Now if you sum this up minus this cancels this, I'll have 25a to be equals to 50. A is equals to 50 over 25, which is equals to 2. Now, let's remove this to create more space. Oh, I wouldn't want to remove this. Okay, let's remove some of this to create more space. Oh, so that if we've gotten A now to be equals to 2. Now let's remember that from here, we have that B is equals to 7 minus 2A. If B is equals to 7 minus 2A, B is equals to 7 minus 2 into 2, which is equals to 7 minus 4, which is equals to 3. And C now, let's solve for C. We can solve for C in equation 2. Equation 2 says 12A plus B plus C is equals to 31. That is, equation 2 says 12A plus B plus C is equals to 31. So that 12 now into 2 plus 3 plus C is equals to 31. That's 24 plus C plus 3 plus C is equals to 31. That means this 27 plus C is equals to 31. That means C now will be equals to 31 minus 27, which is equals to 4. Now, if C is equals to 4, authoritatively, we can conclude that, knowing that our question here says our equation is A over x minus 1 plus B over 2x plus 3, now we can conclude that our A is 2, so that our resolution will be 2 over x minus 1 plus our B is 3, that will be 3 over 2x plus 3 plus 4 over 2x plus 3 all squared. And this is, we've been able to resolve this partial fraction. In our next lesson, I'll still take more questions on partial fraction. I know partial fractions could be a little confusing, so we'll take more questions on partial fraction. For those of you who might have challenge with factorization, we have explained the concept of factorization. I've placed a link in the description below for your access to our lesson on factorization. And also, I have placed links to some other relevant courses that can help you understand factorization. Some of these courses might contain affiliate link. These are ways we have used to support this channel. The affiliate link are without extra cost to you. Thank you and see you in our next lesson.